Well, hello friends and welcome to this session. We will be specifically targeting the break and continue keywords in this particular session. We will be also touching upon the labeled break and continue use cases, when and where to use them. So there is a lot to cover. So without any further delay, let's quickly jump in.
Let us now understand how break keyword actually works. Break works in a switch and loop construct such as for while and to while. Break takes the program control to the immediate parent block of the executing block. Labeled break can take the program control from an executing block to any enclosing parent loop or switch block, or sometimes even outside of it. First example that we are going to see is how break works in a switch statement. So we have initialized a variable driver and assigned it the value val1. Now we are writing the switch block with that same variable. And since the value of this variable is val1, this particular case block is going to execute. So after printing this first statement, it will encounter the break keyword. The break keyword will actually take the program control outside this entire switch block. By switch block, I mean this entire block of code. So the program control will be transferred from this first case outside this particular block. And we will be getting this statement printed. Let us quickly see how this is working. If we run it, we will see that first this line got printed, which is this one, and then after the break, when it exited the switch block, this line got printed. Next example that we are going to see is how we can use the labeled break with a nested switch statement. So let us say we have a switch block which has few cases, case val1, case val2, and a default block as well. And in the second case, we have a nested switch block again, which is switching on this particular literal value of val3. This also has two cases, case valx and case val3. Now based on the value on which we are switching, which is val2, this particular block will get executed. And within this block, since we have provided a switch and the value that we are switching on is val3, this particular block will get executed. So the first output that we are going to get is this will execute. Now after this line, we see the break keyword has been suffixed with a label as well. Now these labels are specifically code blocks in which I want to make the program control jump to. So after this case gets executed, I want the program control to jump outside this internal switch and also outside this external switch and go outside. So whenever I'm going to label 1, it is basically coming out of the entire switch block in itself. So we are going to get the output of this will execute, and after that we are going to get example 3. Let us quickly run this. If we scroll up, we are going to see only this will execute got printed, and then we got example 3. Now let's say I did not use label 1 here. Instead I used label 2. So let's say I make this label 2. So now what will change? So this particular switch will still be evaluating this case, and within this case, this nested switch with val3 will still be evaluating this case again, and it will encounter this break statement with the label of label 2. So the label 2 will take the program control within this case block itself. So the block which is currently executing, it will actually point to that same block. So that's why, as is the case with fall through switches, Once this case is completely executed, it will drop down and go to the default, and we will see this value additionally also will get printed. Let us quickly run this and see. Now if we scroll up, we will see first this will execute got printed, this line, then this will be got printed, which is present in the default block, and then example 3. Now we are going to have a look how we can use the break keyword in a for loop. So let's say we have defined a for loop which will initialize a counter variable at 1, and it will continue the loop until that counter variable is greater than or equal to 20. So ideally this for loop is going to execute 19 times, that is from 1 to 19. Now using break, I need not execute the statement body for this loop 19 times. I can prematurely exit this body. Now how we can do that? We can do that using a break keyword. We can append a condition to the break keyword as when to execute. So here as you can see, if I value is 10, then we should break from the for loop. So this line will stop getting printed once i's value reaches 10, and it will break. And where it will break into? It will break outside this entire for loop, and the program control will be transferred to this particular statement. So once I execute this block, this statement will be printed 9 times for 1 through 9, and then we will break from this for loop, and then it will print example 4. So if I run this and scroll up, we see that the for loop statements are getting printed from 1 and ending at 9. So 9 times this particular statement will get executed. Now we will see how we can use a break keyword in a while loop. So the way the loop has been created, it's similar to the for loop that we just saw. Here we initialize the counter variable outside the loop, and then we are doing this check that I should be less than 20 in the condition check part of the while loop, and the incrementing part of the control variable is done at the last within the code block of the while loop. Here also the loop is designed to run 19 times, starting from 1 through 19, and if we want to prematurely execute or exit from this loop, we can use the break statement, break keyword once again. So when I equals to 10, we will break out of this while loop, and until this condition is reached, this particular statement will get printed. So this statement will be printed 9 times from 1 through 9, because once it becomes 10, it will come out of the loop body and this statement will stop getting executed. Let us quickly check this. So as you can see, within the while, this statement got printed 9 times, from starting from 1 coming down to 9. Now we will see how we can use the break keyword in a do while loop. So since I have already declared an initialized 1, I am reinitializing I value to 1. I start the do while loop and I do the initialization, the condition check and the incrementing part at different location. Initialization is done before we start the do while loop. Incrementing and condition check is done within this statement. Incrementing is done by the postfix increment operator, and the condition check is whatever we are doing in the other two loops, that is I less than 20. So basically this loop is also designed to run 19 times, and once it reaches 10, the value of the counter variable reaches 10, it will break out of the loop. So again this particular statement will be printed exactly 9 times. Let us quickly see that in action. So now if we go here to the do while part, we see that this statement is getting printed again exactly 9 times. Now we are going to dive deep into a little bit more complex implementation. How will break actually behave if we are using break keyword in a nested loop? So in our use case, we are using 3 levels of nesting for a particular loop. So this is loop 1, and within this loop 1 we are having loop 2, and within this loop 2 we are having loop 3. So there are 3 levels of nesting which is involved here. And each of this loop is designed to run exactly 19 times, just like the loops that we have encountered so far. But one special thing to note here is every loop has a premature exit condition using the break keyword. For the first loop, if the value of I reaches 2, it will exit the loop. So this loop, if it is starting at 1, then this loop will run only once. For the inner loop, j, right? If j equals 3, then we are breaking from the jth loop. So if it starts at 1, then it will execute till 2, and then it will encounter this condition and it will break out of the j loop. For the k loop also, it is starting at 1, it will run for 2 and 3, and once it becomes 4, it will break from the k loop as well. So the first loop runs once, the second loop runs twice, and the third loop runs thrice. And within the innermost loop, we are printing out the value of the control variable of each of the loops, I, j, and k. For the jth loop, we are printing out the value of I and j, as k is not available here. And for the ith loop, we are just printing out the value of I. So what we are going to see here is, even though the loops are designed to run for 19 times each, it will run much less than that due to this break keyword implementation in each of them. So the first loop run once, second loop will run twice, third loop will run thrice. Let's quickly run and check this. So as we can see, the k loop ran thrice, the j loop ran twice. This is the first run and this is the second run, and the ith loop ran once. And for each run of the j loop, the k loop ran. So that's why we are seeing 2 blocks of k loops. First block is this one and second block is this one. So that is how it is working. Now coming to the next example, we are ideally going to use this same code that we have used here, albeit there is a little bit difference because we have used labels with the break keywords here. So here again 3 nested loops are present, and the first loop will run once, second loop will again run twice, and the third loop will run thrice, same as above. What we are doing special here is, above each of the loops we have put labels. So the label that we have put here is loop 1, above this particular loop we have put loop 2, and above this particular for loop we have used loop 3. Now what is the purpose of a label? So whenever we are in the innermost code block, let's say the innermost loop, and I want to exit, let's say, the jth loop. So what I can do is, I can directly break to a particular label called loop 2. If we don't use labels, this break statement will break into its immediate parent code block. So from k, it will jump to j. It will not jump outside of j. So due to this, we are using labels. So currently, within the inside loop, right, we are breaking to loop 3 once k reaches 4. Now loop 3 is basically outside this for loop, which is the innermost for loop. So basically this does not have any impact. So the output that we got in the first example would be almost similar to the one that we are going to get here. So now if we run, we are going to see that the K loop runs thrice, the J loop runs twice, and the I loop runs once, as was the case before. And also we have two blocks of K loops, which is this one, and another block of K loop, which is this one, that is running for each J loop runs. So since the J loop runs twice, the K loop also runs twice. But every run of K loop has 3 iterations. So not much difference here. The difference will start happening once we change this label. So let's say after printing the innermost statements, I want to break to loop I and I don't want to go into J. So how we are going to do that? We can directly jump to loop 2. So now I'm breaking to loop 2. So now if we run this, there will be a difference. So if we see here, the K loop ran thrice as it should be, and then there is no J loop run. Directly I am seeing we have reached the ith loop. Now if I don't want the ith loop execution also, what I can do is instead of breaking to loop 2, I will break out to loop 1. This loop 1 is outside the ith loop. So the ith iteration will also not run. Now if I run this, we will see only the kth loop which runs thrice is printed, and both the jth loop and the ith loop is now skipped. Continue can only be used with loop construct such as while, do while, and for. We cannot use continue with switch statement. Break was different. Break actually took you out of an entire code block, whether it is of a switch statement or a for loop, while loop, or a do while loop. Continue makes you skip the current iteration of the loop and jump to the next iteration. We will see that using couple of examples. But first we will see that we cannot use continue with the switch statement. So we have one switch block here, and there are two case blocks and a default block. So in the second case block, I have commented out this continue. If we uncomment this continue, we are going to get one error. If we highlight this error, it is telling continue outside of loop. So we cannot use this continue keyword which is outside a loop. That is one of the major differences between break and continue. Now let us see how we can use the continue in various loops that we have in Java. First example that we are going to see is in a for loop. So we have a for loop which runs from 1 to 19 iterations, and it prints out a statement, that is the current value of the control variable, along with this statement. Now we see there is a if statement as well, and if the value of I is less than 5 or the value of I is greater than 10, then we have used the keyword continue. So that means from this the program control will actually jump to the next iteration. It will ignore the rest of the code block from that point onwards, and it will jump to the next iteration. So this particular statement that we see here will run only for 6 iterations. That is when the value of I is 5 through 10. Any other value will make it skip the current iteration. So now if we print out the values for, we will see that it runs for 5 through 10. It starts at 5 and ends at 10. Rest all the iterations are skipped prematurely. So here we are not exiting the code block, but we are exiting entire iterations of a loop. Next we will see how we can write the same thing using a continue in a while loop. So I have done the control variable initialization and declaration before the loop start. And within the loop, we have used the control variable increment using the postfix increment operator, and the condition is I less than 20, as is the case with the for loop which was above. Here also we have the same check that if the value of I is less than 5 or I is greater than 10, we should skip that iteration. Otherwise, we should continue executing the code block of the current iteration. So this statement again will get printed 6 times from 5 to 10. Now if we run this and go to the while part, we will see that we have 6 lines starting from 5 through 10. Next we will see how we can use continue in a do while loop. Since we have already declared I, I'll just initialize I to 1 here, then start the do while loop, write the same condition as is the case with the other 2 loops that we have encountered so far. And then at the end of the block of statements, we'll write the while condition, and we will also do the control variable increment using the postfix increment operator. So this loop will also run 6 times for values of I greater than equal to 5 and less than equal to 10. If we run this now, we will see that for do while, this is printed again 6 times starting from 5 ending at 10. Now we are going to see the behavior of continue statements using nested for loops. This is specifically a for loop example. You are free to code this example in the other 2 loops, that is do while and while as well. So here actually we have 3 nested loops. So we have the outer loop which runs 19 times. Then we have inner loop which again runs for 19 times. And then we have another inner loop within the inner loop which again runs for 19 times. But here actually we have one condition that if the loop value is greater than 1, then we should skip all the iterations of that loop. For the jth loop, if the value of j is greater than 2, then we should skip all the iterations. And for the kth loop, if the value of k is greater than 3, we should skip all the iterations. So basically when we are skipping this iteration, this outer loop actually run once because rest of the iterations are skipped. Now coming to the jth loop, this runs exactly twice. And for the kth loop, this runs exactly thrice. So if we print this out, we will see the output also reflect the same. So if we go here, we see the k loop runs thrice, the j loop runs twice, and for each run of the j loop, the k loop again runs thrice, and the I loop runs only once. Now let us discuss how we can use a label along with the continue. So in this example, we have basically used the same code block that we have used above. It has 3 nested loops, each running 19 times, and there are specific conditions at which either they will break or skip rest of the iterations. Now let's say I go to the innermost loop. Here, after k attains the value of 3, let's say when k is 4, it continues to loop 3. Loop 3 is basically the next iteration of the kth loop. Now once the kth loop iterations, all the 19 iterations are done, we move to the next iteration of j. Here it is mentioned that once the jth iteration is more than 2, you should continue to loop 2. That is basically iterating over the rest of the iterations of j. And same, once all the iterations, all the 19 iterations of j are done, we come to I, and here it is mentioned that if I is greater than 1, we should break. So here all the iterations are not run. After the first iteration, the control comes outside of the loop. So that is the basic difference. Here there are iterations only one, and for the other two loops all the iterations are executing, but some are getting ignored and some are getting executed. Now if I print out the output of this loop, it would basically be the same as we have seen above. So you see these two outputs, the one that we got from the previous example and this one is basically the same. The difference will start when we actually try to skip to other loop blocks. Let's say from the innermost K loop, once this gets executed, I want to skip the entire iteration of J. So what I do is, instead of continuing to loop 3, I will continue to loop 2. Once I continue to loop 2, if I run this now, we'll see the difference. That K loop is printed thrice, and again the K loop is printed thrice. Now let's take a look at how this happens. So basically when your K loop is executing, after it has printed this statement thrice, it attains the value of 4. When it attains the value of 4, it continues to loop 2. Continuing to loop 2 means that whatever was the current execution context of the jth loop, that gets skipped and the j loop goes to the next iteration, that is of 2. Now when j attains the value of 2, it still runs the entire loop body. So the kth loop again runs and we get the next set of k values. These 3 next lines comes from there. Now again when k attains the value of 4, it continues to loop 2. So the jth loop now starts with 3. Now when the value of jth loop is 3, it continues to loop 2. So basically this kth loop is never run again, hence the output. And we see that at the last we also got I loop I equals to 1. So once all the 19 iterations of the j loop is done, the control will be transferred to this line. So that got printed here. After that, the I will attain the value of 2, which will lead to the break, and the program will come out of this outermost loop. Now if I don't want to print this I loop as well, what we can do is, inside of this inner loop, in this continue, I can directly mention loop 1. So once I mention loop 1, what it will do is, first it will run this thrice. After this statement is printed thrice, it goes to loop 1, and loop 1 means I attains the value of 2, and once I attains the value of 2, it breaks outside. So only this time we are going to see 3 k loop statements getting printed. So if we run this now, we are just going to see 3 k loop statements getting printed. Now coming to the next example, when we are defining a label for a particular loop, we should make sure there are no statements in between the loop. So let's say, let me uncomment this line between the label and the for loop, and also I'll uncomment this if block and the continue statement for that. So this is illegal in Java. We should not write a loop label and then write some statement, Java statement, and then write the actual loop. This is wrong. If you highlight on this, it will say undefined label loop. So it is unable to find this loop 1, though it is declared here. And also this statement will be mentioned as not a statement. So we should not be attempting to do something like this.
Well, that was a long lecture, and with that we come to our control statement series' end, but we are far from over. In the next session, we will be diving deeper into objects and classes. So I am super hyped. Hope you are as well. See you there. Bye.